All right, today we will be learning about trig basics and finding angles. For objectives, we will be able to show the relationship between angles and sides of a right triangle using sine, cosine, and tangent ratios. And we will be able to use the inverse trig ratios to solve for an unknown angle in a right triangle. So, trigonometry is the study of the relationship between sides and angles of triangles. So, given the following right triangle, and we're going to be dealing lots with right triangles in this unit. If we're looking at angle X, which is right here, the side across from that is the opposite side because it's opposite the angle. The side across from the right angle is always the hypotenuse, and then the side touching the angle that's not the hypotenuse is the adjacent side because it's adjacent to it. So if we wanted to know the sine of x, we would divide the opposite side by the hypotenuse. For cosine, the ratio of angle x, we're still at angle x, so the angle across from it is still the opposite side. The side across from the right angle is still the hypotenuse, and this other side is the adjacent side. So if we want to find cosine of x, we would divide the adjacent side over the hypotenuse. If we want to find the tangent ratio of angle x, we're still at angle x. This is still the opposite side. This is still the hypotenuse. And the tangent of x is opposite divided by adjacent. So a little mnemonic device to help you remember these ratios is SO, CA, TOA. Sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tangent is equal to opposite over adjacent. So let's put this to use. Given the triangle DEF, write the trig ratios for angle D. So angle D is this angle right here. We're going to use both the side names and the lengths. So if this is angle D, across from it, that's our opposite side. Across from the right angle is our hypotenuse. And the other side is our adjacent. So I'm going to write my SO, CA, TOA at the top to help me remember. Now you guys have it right above the picture on your note sheet, but you might want to do this on the top of your practices to help you remember what to do. So if we want sine of D, we want the opposite over the hypotenuse. So the opposite side would be FE over the hypotenuse, which is DF. So that's the side names. What about the side lengths? FE is 3. df is 5, can 3/5 be simplified? It cannot, so we'll just leave it like that. Cosine of d is adjacent over hypotenuse. Our adjacent side is DE. Our hypotenuse is DF. And DE's length is 4 over DF's length is 5. And again, that can't be simplified, so we'll leave it like that. Tangent of D is opposite over adjacent. So our opposite side is FE. Our adjacent side is DE. FE's length is 3. DE's length is 4. And again, that one can't be simplified, so we'll leave it like that. Now what if we use the same picture, but we're looking from a different angle? We're looking at angle F. That's this angle up here. So go across from that. That would be your opposite side. Across from the right angle is still the hypotenuse. And then the other side is your adjacent. So basically, if we're looking at a different angle in the same triangle, the opposite and adjacent sides would switch. So sine of F, sine is opposite over hypotenuse. So it would be DE over DF. DE has a length of 4. DF has a length of 5. Cosine is adjacent, so FE. Over hypotenuse, which is DF. FE has a measure of 3. DF has a measure of 5. And then tangent of F, opposite is DE over adjacent, which is FE. And so we have a ratio of 4 over 3. So now let's look at some trig ratios where we need to simplify our answers. So remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent equals opposite over adjacent. So if we're looking at angle A, across from that, that's our opposite side. Across from the right angle is our hypotenuse. And our other side is our adjacent. So if we want sine of A, we want the opposite side, which is 2 root 3, over the hypotenuse, which is the square root of 21. Now if you notice, we have a square root in the top and a square root in the bottom, and they are both divisible by 3. So we're going to simplify 3 over 21 would simplify to 1 over 7. So I'm going to simplify this to 2 over the square root of 7. But we can't have a square root in the denominator. So we are going to rationalize our denominator by multiplying the top and the bottom by the square root of 7. Because technically, square root of 7 over square root of 7 is just equal to 1. So we'll have 2 square roots of 7 over the square root of 7. If we're multiplying it by itself, that would be squaring. if you recall from last class, square and square root undo each other, so we would be left with 2 square roots of 7 over 7. Let's look at cosine. We want adjacent over hypotenuse. So 3 over the square root of 21. Now we can't simplify at the beginning this time because the top doesn't have a square root to simplify with the square root on the bottom. So we need to get the square root out of the bottom still though, so we're going to multiply. In the first one, we multiplied it by square root of 7 because square root of 7 was on the bottom. This time, we're going to multiply by square root of 21 over square root of 21 because we have a square root of 21 in the denominator. So we would get 3 square roots of 21 over the square root of 21 squared, which would equal 3 square roots of 21 over 21. Now, here in the first one, 2 and 7 can't be simplified, but can 3 over 21 be simplified? Yes, it can. It would simplify to 1/7, so we would have the square root of 21 over 7. And finally, for tangent, we want opposite over adjacent. Opposite is 2 square roots of 3. Our adjacent side is 3. 2 over 3 can't be simplified, and we have no square roots in the denominator, so there's nothing to simplify there. All right, for our next type of problems, we're going to start finding the angles in some of these triangles. Now, this is very, 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 very important. Your calculator must be in degree mode before you do this. If it is not in degree mode, you are 100% most definitely going to get the wrong answer. So, as soon as you walk into the classroom next class, you want to pick up your calculator and put it in degree mode. So, how do we do that? We're going to look at our calculator. We want degree mode. Do we see a mode button? Yes, it is right next to this blue second button. It says mode. If you scroll down 2 lines, you see the word degree here. We're going to arrow over to it, push enter on degree, and now you can see that degree is highlighted. It's got the dark background. That's exactly what we want it to look like for it to be in degree mode. So then I can push clear, and that'll take me back to the main screen, and that has saved that we are in degree mode. You need to check your calculators, make sure they're in degree mode every time you come into class. So, to find the measure of angle A, we need to use the inverse trig buttons, which are sine inverse, cosine inverse, tangent inverse. So if you think back to math that you guys already know how to do, the inverse of multiplication is division. The inverse of adding is subtracting. So the inverse of tangent is just tangent inverse, this little symbol here. So if we want to get A by itself and find out what it's equal to, A would equal the tangent inverse of 1.73. So let's look at where that is on our calculator. It is written in blue right above where it says tangent. So we're going to push second tangent, that'll pull up tangent inverse, and then 1.73. Close the parentheses, and we get 59.97. Now the directions say to round to the nearest degree. That means the nearest whole number. So the 9 would make this 9 round up, so it would be 60.9. degrees, and you need to make sure you are including the degree symbol. It is very important. What if we're dealing with a fraction? We can do the inverse trig functions on fractions as well. So if we want to get a by itself, to undo the cosine, a would equal cosine inverse of 31 over 50. So on our calculator, cosine inverse is above cosine, so second cosine 31 over 50. For rounding to the nearest whole number, the 6 would make the 1 round up, so it would be 52 degrees. Now the third one makes us do a little work before we figure it out. We want to find the measure of angle A, so right here. So this side across from here is our opposite side. The one across from the right angle is the hypotenuse, and that leaves this side to be the adjacent. So the two sides that we know are the opposite and adjacent. Which one of our ratios, sine, cosine, or tangent, uses opposite and adjacent? You're right, that's tangent. So the tangent of A equals 5 over 5. So if we want to find A, we need to use tangent inverse. Now what does 5 over 5 simplify to? That's right, it simplifies to 1. So A equals, let's type it in our calculator, second tangent for tangent inverse of 1 is 45 degrees. For our final example, find both of the acute angles in the right triangle. Round to the nearest degree. So we're going to round to a whole number. So which one do you want to find first? Let's find M first. This is M, that's angle M. So across from it is our opposite side, and across from the right angle is our hypotenuse, and the other side is our adjacent. Since we know the opposite side and the hypotenuse, we're using which ratio? That's right, sine. So sine of angle M would equal 5 over 13. So M equals sine inverse of 5 over 13. Type that in our calculator. Second sine of 5 over 13 gives us 22.6, which, since we're rounding to the nearest degree, would be 23 degrees. Now, if we want to find the measure of angle R, we're going to have to relabel our triangle because we're dealing with a different angle. So angle R, across from it, that's our opposite. Across from the right angle is our hypotenuse, and our other side's our adjacent. So if we want to find angle R, we need to use adjacent and hypotenuse, which is cosine. So cosine of R equals 5 over 13. So R is equal to cosine inverse of 5 over 13. If we type that in our calculator, second cosine of 5 over 13, we get 67.3. Since it's 0.3, that wouldn't change the 7, so it'll stay that r is 67 degrees. Now, how can we check that these are the right answers? We know that all the angles of a triangle add up to 180. Since the right angle is 90 of that, that leaves 90 for the other two angles. Did those two numbers add up to 90? They do, so we know that's the correct answer. Finally, for your summary, use your own words to describe how to find the side of a right triangle we call the hypotenuse and the sides called opposite and adjacent in relation to an acute angle. That's all for today. See you in class.